All right, guys, we're going to try to help you understand how it is that the rock layers at the bottom of the ocean are different ages. So you saw that image with all the colorful strips of rock that indicated different ages on the previous image that you saw. What you'll see here is on my table. What I have is I have two pieces of colored paper, two pieces of blue paper. Those represent continents, and the purple strips in between represent ocean floor. And you'll also see that there's a crack here in this table, and that crack is going to indicate the place where the magma is seeping up. Okay, and so right now we've got rock on the ocean floor, again the purple, that's already formed, and we've got the continents over here on the side. And what's going to happen, remember, at a divergent boundary is that the two plates are going to slide apart from each other. We're going to watch this motion. As the magma comes up, it's going to push, and as the convection currents are going under the earth, like so, you're going to end up with these two plates pulling aside, and more magma is going to come up in between. These new strips that you see here are new rock that has come up to the surface and formed in the intervening millions of years. So remember that we had the continents out to the side, the blue, and then we had the purple strips in the middle, and then we had those were the original rock of the ocean floor. And then we have this new rock that's formed. The magma has seeped up through the crack and has solidified over years, and this rock has formed over the course of maybe a million years or some number of millions of years. Okay, so we've got older rock, newer rock here, and then the continents off to the side. Okay, now we have a new image for you, and you can see that the plates have continued to move apart from each other, driven by those convection currents in the mantle. The original oceans are farther and farther away. I'm going to actually raise the computer up so you can see the whole thing a little bit. Hopefully you can see that now. I'm going to come back down. So you can see that we have the original purple rock, ocean floor rock, off to the side. That's the oldest rock. Then you've got the next, the newer rock, which is the blue in the middle to the sides. And then you've got this newest rock, the green, directly in the middle, right near that crack where the boundary is between the two plates. Remember, these whole things are plates. This is one plate over here. This is another plate over here. And we've added newer rock in the middle there. And now again, you can see that the rocks have continued to move apart, and we can see that we've added a new layer of rock that's newer. The yellowest rock is now the newest rock. Green is a little bit older. Light blue is a little bit older. Purple is even oldest. And then you've got the continents off to the side. And now even more magma has come up because the convection currents have been pushing off to the side the rock. And so we've got more magma has come up and formed into solid rock at the bottom of the ocean. And you have now these orange stripes representing the newest rock. Yellow is a little bit older, green a little bit older, and so on and so forth. And finally, we've added in the last layer, the last set of rocks in this aerial view. We've got nearest the crack, we've got the red stripe representing even the newest rocks that have formed at the bottom of the ocean from magma that seeped up through that divergent boundary and solidified and turned into rock. So we've got oldest, youngest in the middle, oldest out to the side. So I'm going to lift the computer up so we can see all the different colors. Hopefully you can see all of the colors that we were looking at there. And you can see that the youngest rock is in the middle, the oldest rock and the continents are furthest out to the side.